Today we are going to discuss a numerical problem on heuristic search. As we all know, heuristic search is the informed search techniques in which we have some information in addition to the given problem definition. When we are given some additional information, we are able to find out that which direction is more promising to reach to the goal, irrespective of in comparison to the other one. So here I have taken the concept of heuristic search. In this I am going to take a numerical problem that will be solved with help of greedy best first search and A star search. So I have taken the concept from artificial intelligence by Russell and Norwich. So I'm starting with greedy best first search. In best first search, what happens? We have some initial state, and from that initial state, we take the next possible states. We expand the next possibilities. When we search these next possibilities, then we see which one is best. So firstly, I am taking the greedy approach to find out the best first search. When we have this greedy best first search, in this the evaluation function. What is evaluation function? Evaluation function tells us that what is the fitness, what is the evaluated value, how good this node is, this possibilities, and how good this possibilities. Every node will have some evaluation function. So when we have greedy best first search, we will have the evaluation function same as the HN, the heuristic. What is HN? HN is actually the estimate of cost from node N to the goal. Evaluation function of a node N is the estimate from N to goal, this particular node to goal. Okay, and what we can have as the possible estimates, for example, straight line distance, SLD. SLD is straight line distance. What is straight line distance? When we are able to, when we connect the 2 points, source and destination, in a straight line, that is our straight line distance. What we do in greedy best first search? In greedy best first search, we expand the node that appears to be closest to the goal. So we are greedy in approaching to the goal from this point. This is our intermediate point till which we have already visited. That is our intermediate goal N. So we'll start from N, we'll take some action, and we will reach to some intermediate goal and finally intermediate node, and then finally we will work out for goal. So here I am taking firstly the numerical problem for greedy best first search. So I have taken this one diagram. In this, my source is given as S and G is the destination. Okay, so what is greedy best first? In which the heuristic value is given. The heuristic value in this particular diagram is mentioned on the particular nodes. For example, for S, 17 is the heuristic value to reach to goal G. From C, 4 is the heuristic value to reach to G. So on each node, we are given the heuristic values. What else is given? We have to pay the cost to reach from one state to another. For example, from S to A, I need to pay 6. The cost is 6. Okay, from S to B, it is 5. From B to D, it is 7. So we are having here particular values which are mentioned on the edges. Those are weights. The weights will be defining the actual cost. The actual cost from D to F is 6. So this is the actual. On the edges, we are having actual cost, and on the nodes, we are given the heuristic value. So now let us do this problem using greedy best first search technique. So if I take this source and destination, so S is source, G is the destination. So what we will do the tree search using greedy best first technique. Okay, and we will use the heuristic value. So if I start from here, my starting node is S. S is my starting node. Okay, now what is value of this heuristic value? That is 17. So let me repeat here. In greedy best first, Fn is Hn. That is the heuristic value only. The evaluation function is same as the heuristic function. So the heuristic values are given on the nodes. So we are given actually the values of the evaluation function. So what is the value of S? S is having the value 17. Okay, so value is 17. Now the question is it goal? No. As it is not goal, so what we need? We need to expand it. Okay, so what are the neighbors? A, B and C. So the three neighbors are A, B and C. These are my neighbors. Okay, so what is now Fn for these nodes? For A it is 10, for B it is 13 and for C it is 4. It is 4 for 13. Now if I see this path, which I'm greedy, I'm having the greedy approach. So greedy approach means the minimum heuristic value I will take. So what will be selected after S? Firstly, S was expanded. Now what is selected next? That is C. Now we will see, is it goal node? No, it is not goal node. Okay, so we need to expand it. So what are neighbors of C? Neighbors of C are S and D. Neighbors of C are S and D. What is heuristic value of S? We already know 17. What is heuristic value of D? It is 2 only. So these are the heuristic values. Now we are having nodes with heuristic value 10, 13, 17 and 2. From here we are getting the values. These are mentioned with the nodes. So here I am getting the minimum value as 2. So what I will select? I will select for next processing D. So D I selected. Now I got D. Now I will check, is it goal? No, it is not goal. Okay, so we will expand it. So D is having 3 neighbors, B, C and F. The 3 neighbors are B, C and F. What is the heuristic value of B? It is already, we know, 13, 4 and 1. 13, 4 and 1. When we see now all the unexplored nodes, what are unexplored nodes? A, B, this one is B, C, F. Okay, during implementation, we will not take it. S we will not take because we will maintain the nodes of visited and not visited. Okay, so if we see here, what is the minimum value? Minimum value is 1, which is for F. So F will be selected. Now we will check F is goal. No, F is not goal. So what we will get? We will see the neighbors of this. Neighbors are E, D and G. E, D and G. Okay, E is having value 4. D is having value 2 and G is having value 0. So minimum is 0. So we will select minimum among all 10, 13, 17, 13 again 4, 2, 0. The minimum is 0. So we will select G. Now we will check, is it goal? Yes, it is goal. So we got the goal node. We have reached to the solution. So what is our path that we have found? S to C, S to C, C to D, D to F, and F to G. Okay. So what is our path length? 10 plus 6, 16 plus 6, that is 22 plus 3. So we have got the 25 cost. This is result of our greedy best first search. This is greedy best first. Greedy best first search. 25 will be the resultant. Okay, so what we have done, we have found the solution from the given problem to reach from S to G using greedy best first. Okay, by doing the next question, we'll find out that this is not the optimal solution. So it may be the case that the greedy best first, we are finding the solution to take the best result to reach to the goal from the current position, but that may result in suboptimal solution, a solution which is actually complexer or bigger than the optimal solution. Okay, so now we'll do the same question using A star search technique. So now let us firstly revise the A search method. So what was there in greedy best first? We were taking evaluation function simply as the next estimate from current node to the goal, that is HN. Now in A star, what we do, we try to avoid the path which are already expensive. It means we will consider that cost also which we have paid to reach to this intermediate node. In the previous method, greedy one, we were not considering the cost that we have already paid to come to an intermediate node. So in this, we will calculate that also. So we have taken Fn is equal to Gn plus Hn. Now what is Gn? We started from a particular initial state and then we will reach to N. Gn is the cost to reach N. Now this is my intermediate node. So this is the actual cost that I have already paid to reach from initial node to this current node. Okay, and now further I have to go, so there I will use estimate, that is my Hn. So it is Gn plus Hn. Gn is the cost paid so far to reach N, and Hn is the estimated cost from N to the goal. That is our evaluation function. So what Fn will be? What is the evaluation function in this particular case? That is estimated total cost of path from source node to goal through N, through this intermediate node. So now let us understand the method with the help of our example. We are taking the same example. Okay, now what is my Fn? My Fn is Gn plus Hn. Okay, so now let us start from the initial state. The initial state is S. S is my initial state. Now what is the difference? I am considering that cost also which I have already paid to reach to this node. So what I paid to reach to S? 0, because this is my initial state. Nothing has been traversed till now. So we will take it 0. 0 cost I have paid to come to this. Now, what is the estimate? What is the heuristic value? 17. So it will be 0 plus 17, as it is only one node. So we will select this and we will check, is it goal? This is selected. Actually one node was there, so we selected that. Now the question is it goal node? No. So as it is not the goal node, we will expand it. What are the neighbors? A, B and C. So what are my 3 neighbors of S? One is A, another one is B, and the last one is C. Okay, what is now the cost paid to reach to A? That is 6, to B 5, to C 10. So it is 6, 5 and 10. This is the cost paid to reach. And what is the heuristic value of A, B, C? 10, 13 and 4. This is 10, this is 13 and this is 4. In greedy best first, we were greedy in paying less to the rest of the part. But here, we want to pay less for the whole path from source to destination. There, we were just considering from current node to destination. Okay, so it will be, the total will be Gn plus Hn. Hn is 10, Gn is 6. So, it will be 16. Okay, here Hn is 13 and Gn is 5. So, it is 18. This is 4 plus 10, 14. So, which one is minimum? That is C. From among 16, 18 and 14. What is the minimum value? Minimum value is 14. So, we will select C for expansion. The third node will be expanded next. Okay. So, but before expansion, we have to apply the goal test. Maybe it is the goal. Okay. So, we selected C. Now, we'll check, is it goal node? No, it is not goal node. Goal node is G only. Okay. So, we will select it for expansion. Now, what are neighbors of C? C is S. Neighbors are S. Now, see, we are using the cost to reach here. Okay. So, if we will take S also, then definitely we will get the path length 10 plus 10, 20, just the double. Okay. So, we can simply avoid here the nodes which we have already considered. Okay. So, already considered is S and now we are considering C. So, C's neighbor is D. What is neighbor of C? That is D. And what is the cost paid? That is 10, then 6. Okay. There is only one neighbor. What is the heuristic value of D? That is 2. Heuristic value of D is 2. Now, what is the cost paid to reach here? 10 plus 6, that is 16. So, what is the Fn for this value node? What is the evaluation function value? That is 18. Now, we will see all unexpanded and we will find out the minimum one. Minimum one is 16, that is A. So, next turn will go to A. Next selection is A. Now, we will check, is it goal? No, it is not goal. So, we will expand it. What are neighbors of A? That is E. Now, what is the cost paid to go from A to E? That is 6. What is the value, heuristic value of E? That is 4. So, what is evaluation, function evaluation value? Yes, 6 plus 6, 12 plus 4, 16. So, what is minimum among these? Again, 16 values. So, E will be expanded. Now, what are neighbors of E? Neighbors of E are A, which we have already selected, and then B and F. B and F. What is the cost from E to B? That is 6. From E to F, that is 4. What is heuristic value of B? That is 13. What is heuristic value of F? That is 1. Now, let us calculate the function, evaluation function value. That will be 6 plus 6 plus 6. Okay, it means 6 3s are 18 plus 13. It will be about 31. Okay, and this will be 12 plus 4, 16 plus 1. This will be 17. Evaluation value. So, what is minimum value here? Now, let us check again. From A, we are having 6, 6, 12 plus 4, 16 plus 1, 17. So, what will be the next evaluated value? that will be 17 to be selected, because we are having 31, 17, 18 and 18. Okay, so we will expand F. From F we are having path D and G. G is at distance 3 and D is at distance 6. We can see this path. Okay, here what will happen? 6, 6, 12 plus 4, 16 plus 6, 22. And what is heuristic value of D? That is 2. So if we move on this path, we will get 24. If we move on this path, we will get 20. Why we are getting 20? It will be 2, 6 plus 6, 12 plus 4, 16 plus 3, 19 plus J 0. We will get here 19. Now we will compare all the value. What is minimum among these? Minimum among these is 18. So we are selecting B. Why we are selecting? Because from the evaluated nodes, the minimum value is 18. Now we will go to B. Now from B we will get the neighbors E and D. E and D. From B, E is at 6 distance and D is at 7 distance. And E is having heuristic 4 and D is having heuristic 2. So what will be evaluation value for this? 5 plus 6, 11 plus 4, 15. For this, 5 plus 7, 12 plus 2, 14. So we get D as the next minimum value. The next minimum is D. From D, if we see, we are having neighbors C and F. C has already been worked out. So now we are having option F. F is at what distance? F from D, it is at distance 6. And what is the heuristic value of this? 1. So what we are getting here? 5 plus 7, 12 plus 6, 18 plus 1, 19. We got the value 19, which is higher than E. It means we should explore E first. Now if I take E, from E we are having neighbors F and we are having neighbors B. Okay, so from E we are having neighbors B and F. We are avoiding some nodes which have been already calculated for maximum values, but we may get it. Why we are avoiding? Because if we will go on the same path and come back again, that will make the amount double, the cost double. Okay, so we are taking only those possible expansions which are falling on that particular path for the first time. Okay, so if you consider B to E, then again E to B, then it will be simply from B to E and then again to B, then it will simply be the double cost on that particular path. Okay, so we will simply check F. For F, we are having E to F, E to F4 and F value is 1. So what will be the evaluation function value of F? That will be 5 plus 6, 11 plus 4, 15. Again, F is the minimum one. So now we'll consider this F. Now what are the F values? Here from F I am having neighbor D and I am having neighbor G. D and G. Okay. So from F to D you are having 6 and D cost is 2. From F to G we are having 3 and the cost is 0. So again we will calculate values for these two. This will be 5 plus 6, 11 plus 4, 15 plus 6, 21 plus 2, 23. And this will be 5 plus 6, 11 plus 4, 11 plus 4 is 15 plus 3, 18. So if I check all these values which are not yet expanded, 18 is minimum. So I am selecting this node. I selected G. Now I checked, is G goal node? Yes. So we'll stop here. So this is the way to apply the A star algorithm for heuristic search. In this, we are given the actual value. Actual value means the actual cost from going one node to another node. And what in addition to this problem, in addition we have the heuristic value, that is estimate of the cost from in all the intermediate states to the goal state. So this way we can apply heuristic search on the given problems. This is one example of informed search. So in this particular video, we have done heuristic search method numerical for two approaches, greedy best first search and A star search. Thank you.